All right, welcome to section 2.4 where we're going to be talking about rotations. Again, shouldn't be too difficult. In comparison to what we've done before, this actually can be a little bit more challenging because it actually requires some mental manipulation of the pictures. And sometimes that's not always easy for people to do. And it's actually what we call spatial reasoning skills, but that's some bunch of science mumbo jumbo that we're not going to get into right at the moment. But one of the easiest things about rotations that will help you do it is literally rotate your paper around. But we'll get into that in a minute. So what is a rotation? It's transformation that turns a figure, okay? So we basically are turning a figure. If I were to draw something right here, here's a square, I'm going to literally turn it. Notice really, and I'm rotating it. That's all it is. All right, so I'll take this piece of paper for now. For later. Center of rotation is where a figure is rotated around. So for instance, here's my picture. I can actually place my center of rotation right here, and I can rotate my picture along that rotation point. Or if I don't like that, I can put my center of rotation here and I can rotate it around that. And notice that depending on where my center of rotation is, it changes the position of where my final picture might be. All right, so just keep that in mind. But luckily for us, we're mostly going to do our rotations around the origin, so we don't have to get too complicated. Angle of rotation is the number of degrees a figure is rotated. So if this is my center of rotation and I want to rotate it just a small amount, whatever that degree is, we can actually kind of show it by using a protractor if we wanted to. Maybe I only want to rotate it by 15 degrees, which would be something like this. However, normally what we're going to be doing is rotating 90 degrees. And remember what 90 degrees is. It's basically it makes kind of like a box here if I were to look at an axis point. So if I was to say this was my starting point right there, and I want to rotate it 90 degrees, I would basically move my paper so that my line was going into a different direction. If I was going up, I would end up left or right. Nothing overly complicated, and you've done this before, so I'm not going to spend a lot of time on describing what 90 degrees is. If you need some help in figuring out what 90 degrees is, just let me know. But that's really what we're counting by, is by 90s. Okay? So the other little issue is what we call clockwise and counterclockwise. And again, this is not too terribly complicated because it should make sense. If I am rotating clockwise, it means I'm rotating like in this direction, okay? Because a go clockwise is this direction on the clock. Counterclockwise would be in this direction. And again, should be pretty much intuitive. You should know what a clock looks like. So if I wanted to rotate this little piece by, let's say, 90 degrees, and I wanted to rotate clockwise, I would rotate my paper clockwise 90 degrees. And if I wanted to do it negative, I would go back the opposite way. And we'll do some more on that in just a second. All right, so what we're going to do now is do this next problem. It says, tell whether the shaded figure is a rotation of the non-shaded figure about the origin. If so, give an angle and direction of rotation. So what we're doing is we're seeing if this can be rotated about the origin to make that shape. And we could do this a couple of different ways. And one, it's really hard to do it on camera, but I'm going to do my best here. We know, I can see it through my picture here. I can see that my origin is right here, and my original picture looks like this, and I'm just kind of setting it up. And now I'm going to rotate it about the origin, okay? And I'm going to just kind of draw a sketch. So here's my origin, and now I'm going to rotate it. And what I'm going to do is, right now it's in this is the first, this would be the second quadrant. And the picture I'm looking at needs to be in the fourth. So I've got to move it from this second quadrant. I'm going to draw this out so you can see. And I'm going to rotate it so that it looks like it's in the fourth. All right, when I do, I've rotated it 90 degrees. It's now in the third quadrant, and I'm going to rotate it again, and it's now in the fourth quadrant. Now, this is the way it would look. Now, let's compare it. Is that the same shape? Absolutely not. So the answer to this is no, it is not a rotation. Now, what happens if you don't have a piece of paper, which like on the EOG or anything like that? Well, simply put, you're going to have to rotate it manually and try to keep it in your mind. So just to kind of show it to you, I'm going to put a screenshot of this picture up onto the side of the screen here. And now I'm going to rotate it so you can see. So right now, my original picture is in the second quadrant. I'm going to rotate it. It's now in the third quadrant, and I will rotate it one more time, and it is now in the fourth quadrant. And as you can see, where this is does not look like the other one. Now, let's do the next one. 2. Well, again, I can use a piece of paper and trace over it and then rotate it, but this time I'm not going to do that. I'm just going to kind of show it to you what it looks like. So I'm going to rotate this. Right now it's in the third quadrant. I need to rotate it to get it to the first. So I'm going to have a little picture on the side of the screen, and let's look at it. So let's rotate it. Right now I've rotated it 90 degrees. That was counterclockwise, and it's in the fourth quadrant. And now I'm going to rotate it one more time, and now my picture is in the first quadrant. And if you compare the two pictures in your mind and on screen, like you can see, yes, this was indeed a rotation. So what did I do? Well, let's go back through it one more time. I rotated it 90 degrees counterclockwise, and then I rotated it another 90 degrees to make a total of 180 degrees counterclockwise. All right, so yes, and the angle was 180 degrees counterclockwise. So now I'm going to do the next piece. It says the vertices of a triangle are 1, 1, so I want to plot that. 3, 1, so plot that, and 3, 4, plot that. And so now I have my vertices, I have my edges, not my edges, but my points, and now I can draw my triangle all the way, and it looks like that. Now, the problem tells me that I need to rotate the triangle as described. So it's telling me to rotate it clockwise. So clockwise would be in that direction. And I need to do it 90 degrees. So I'm going to rotate it 90 degrees. And right now, it's in the first quadrant, but when I rotate it 90 degrees, it's now in the third quadrant. Okay, so here's what we're going to do. Now that I've rotated it, I can go ahead and kind of label my points here. Now, we're going to pretend that this is no longer the y, but it's now our x-axis, and this is now our y-axis. And when I do, I can relabel this, that this would be 1 and negative 1. I'm going to write it over here so we can see it. We have 1 and negative 1. The next point would be 4 and negative 3. And the next point would be 1 and negative 3. Okay? All right, so that's by using our imagination and pretending that these axes have been relabeled properly to be this to be the y and this to be the x, and we can relabel these as negative 1, negative 2, so forth, so on. I hope you get the idea. So now that I know what my 3 points are, I can rotate it back to where it needs to be, and let's plot those points. 1 and negative 1 would be here. 4 and negative 3 would be here. 4 and negative 3 would be here. The next one would be 1 and negative 3. Those are my 3 vertices. And now I'm going to connect my dots. All right, and now I have my picture, okay? And I can prove this again to show that this is indeed, so I'm going to put a picture up on the side here. This right now, this is where it currently is, where I drew 4. Here is my original picture, and as I rotate it, look at what my picture looks like. So this was the original, and on the other side of the screen, you actually see what it looks like rotated. So these two shapes are indeed in the right positions. So this next one is actually kind of difficult because one reason why this is difficult because I can't really rotate my paper. And the reason why I can't rotate my paper is because it's telling me I have to go about doing my rotation around the vertex A. That means that this point cannot move. It has to stay the same. Whereas when these other ones, when I was able to rotate around the origin, it moved the entire shape. This time, it's only going to move these 2 points. So, again, we could use a piece of paper to help us out on this, but it's kind of difficult, so we've got to use a little bit of imagination here. So, if I were to do this point right here stays the same because if I were to move it, it's going to be, that position is going to remain, and the only thing that changes is here. So let's rotate it counterclockwise, and let's start off with 90 degrees. So that means that this side right here rotates 90 degrees up, and so that would give me to this side. So this got rotated 90 degrees. And then this side was also rotated 90 degrees. And the shape doesn't change, so we can actually draw our line here to go to this point. And so what we've done is we've kind of created like a little shadow. We've rotated this shape by 90 degrees, and at the same time, it kind of keeps us on track. So now let's do another 90 degrees. So this side is now going to go here. And then this side is going to go here. All right, so I've rotated it another 90. So I went from 90 to 80. Now I need to do one more time. That means that this side is going to go here. And this side will now go here. And I can erase my 2 previous ones because I don't need those anymore. And just to show the difference, I'll do it in color. So as simple as the concept is about rotation, so as you can see, the rotation concept is easy, but when we get to where we're going about a certain vertex, it gets a little difficult and you've got to take your time with it. So the problem at the top of your screen for number 6 states, a triangle is rotated 180 degrees about the origin. Its image is reflected in the x-axis. The vertices of the final triangle are as shown. What are the vertices of the original triangle? So this problem has given you the vertices, and when I plot it, it looks like this. This is the triangle after we have manipulated it and did the transformations of the rotation and a reflection. So our job actually is to work backwards in this problem. So this is basically the finished product. We want to know where was this triangle on the coordinate plane before we began. So the first thing that we do is we go backwards. Here is our last picture, and then it says the image was reflected in the x-axis. So that's what we're going to do here. We're going to reflect it. And remember what in the last video was, however far away we're reflecting, that distance stays the same. And since we're reflecting in the x-axis, this point right here would be reflected here because it's only 1 point away. And then this one would be reflected 4, so 1, 2, 3, 4. And then this one would be its matching pair. So what we've done is we have reflected it, and just for the sake of argument, I'm going to break a rule and just do a pin here so we can see what the second step looks like, okay? Because we're working backwards. So now we know what the picture looked like before it was reflected. All right, now we're going to go back to the first sentence. It says that it was rotated 180 degrees about the origin. So we're going to look at this and we're going to rotate it 180 degrees. So we're going to rotate it 90 and we're going to rotate it 180. So just watch what I did. We had it here. Now we're going to rotate it 90. And now we're going to rotate it 80. And so now we can look at this and kind of come up with our points here. So I have 3 and -1. Okay. The next one would be 2 and -4. And the last one would be 4 and -4. Basically, after we rotated it, that position that it's in is now in the 4th quadrant, which matches up with what we have. So let's kind of move everything back, and everything's upside down with my numbers here, but that's okay. We'll just kind of fix it and rewrite it on the side. We know that it's going to be 3 and -1. We know it's going to be 2 and -4, and we know it's going to be 4 and -4. So let's plot those. 3 and -1 would be, let's do a different color. 3 and -1 would be here. 2 and -4 would be here, and 4 and -4 would be here. And now we can draw it. All right. So according to our problem, here's our original triangle, and we're going to rotate it from 90 to 180. So this would be 90, this would be 80. And now it's in the 2nd quadrant. We can check our points, and what we would find out is it's actually going to match up with what we had done earlier, this 2nd step. And now that we've got this in its correct position, we can reflect it across the x-axis to get this. So indeed, our measurements do work. Now, I will be honest with you, this right here is very tedious. I will be with reflections. Even making this video, I had to stop, pause, redo something because it just didn't look right. Reflections and rotations, when you put them together, it gets very confusing. So please take your time on this next set of problems. And as always, you know how to find me and to ask for help. And I'll see you in the next one. Bye.